Hello, my dear students. I hope you're all doing well. My name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. So, continuing with our series on numericals. Currently, we are solving the numericals. One video has already been uploaded, so make sure that you learn from there also. 3 questions have been discussed, and in this video itself, we'll try to discuss another 3 questions. So likewise, okay, we will be completing all the numericals given in the exercise question. So we will be solving question number 6 today. So without wasting any time, let's go and solve the questions together. But before we start, what I want you to do is you have to grab a notebook, grab a pen or a pencil, and please follow. Okay, please follow what we are doing here so that you will learn. So let it be a practice at the same time. Okay, master this numerical problem. So let us do that. Okay, and let us now go and solve this numerical problem together. So the first thing that one should do to solve a numerical problem is to read the question. Okay, read the question again and again, okay, once, twice, thrice, until unless you get something, okay, to start. So read the question, and that's what we will do here. So let us read the question together. So question number 6, the question reads, a copper wire has diameter 0.5 millimeters and resistivity 1.6 ohm meter. What will be the length of this wire to make its resistance 10 ohms? How much does the resistance change if the diameter is doubled? Very interesting question. Okay, very interesting question. Now, after reading the question, now whatever we get to extract, we'll discuss here first. So we have already read the question once, and on reading the question, we get to know that there's a copper wire who has a diameter 0.5 mm. So we have a copper wire, okay, and the diameter of this copper wire is given to you. It's 0.5 millimeters. And resistivity is given to you. Resistivity is rho. Okay, rho is given to you 1.6 into 10 to the power minus 8 ohm meter. The question is asking us what will be the length of this wire. So the length, okay, they are not sure about the length. So how long is it? We don't know. So they want us to find the length. They want us to find us the length, okay, to make its resistance 10 ohm. So the resistance of this wire is given to us. Resistance is 10 ohm. So these things we know. So whatever we have written here, we can always write down in the question, in the answer as given. So let's start now. So you write given, and in the given, whatever you have understood or whatever you have extracted, you can write it here. Okay, so given, you write here what is given to you. Diameter is given to you. Diameter is given to you. Diameter is capital D. Okay, diameter is given to us. It's 0.5 millimeters. Now, after that, what is given to us? Resistivity is given to us. Resistivity is given to us. Resistivity is rho. It is 1.6 into 10 to the power minus 8 ohm meters. And even resistance is given to us. Resistance of the wire is given to us, which is R, is given to us 10 ohm. What we are supposed to find? Length. We are supposed to find L. So put a question mark. Now, well, see, which formula are we going to use here? Well, we are going to use the formula, okay, where these values will be handy. We are given the value of resistivity. Rho is there, L is there, and then diameter and radius are there. Okay, so name a formula which has got rho and L. Do we have a formula which has got rho and L? Yes, the formula is that of resistivity. So resistivity formula is rho L by A. So this is the formula we'll be using, okay, my dear students. So we'll be using this formula. We have resistance given to us. We have resistivity here. We have length, which we are supposed to find. And yes, area is not there, but we can find area because diameter is provided to us. Diameter is given to us means area. We can find area. Okay, using the help of the diameter, we can find area of cross section. Okay, area, this is area only. They've given you diameter, so that means we will be finding area by ourselves. So we have this value, we have this value, this is what we are supposed to find, and this we will extract first. Okay, so our job is to first find area, then only we'll be able to find length, but the formula will be this. So this is the formula. Okay, it confirmed that this will be the formula. So now certain things we have to do, we have to take care. The first thing is look at the diameter, look at the diameter and focus your attention to this part. This is in millimeters. Okay, now this is in millimeters and we have to change this, but to which value are we going to change? We will change this value to the value of resistivity. So this is a fixed, okay, resistivity has got its own unit, ohm meter. So we'll change to meter. So millimeter we have to change to meter. So here you are required to know the unit conversion. You are required to know the unit conversion. So how many, okay, to convert millimeter to meter, what should you do? Should you divide or should you multiply? The answer is you should divide. You will divide by 1000. So let's first convert this millimeter to meter. So it will be 0.5, okay, divided by 1000 meters. Once again, pay close attention. From here, from this value where we have transformed to this value, so many things have changed here. So many things, a big thing has happened. What has happened? First of all, the unit has changed from millimeter to meter. We are changing to meter. All right. And then it was in millimeter. Now we are changing to meter. So millimeter to meter, okay, it's division by 1000. Remember this, okay? When we change from millimeter to meter, you'll have to divide by 1000, for which you will have to know the unit conversion. If you don't know the unit conversion, let me give you here. So it's like this: milli, centi, deci, meter, deca, hecta, kilo. This is millimeter, okay, centimeter, decimeter, meter, decameter, hectameter, and kilometer. All right, you either go down or you either go up. Now this is from millimeter to meter. So from millimeter to meter, you are going down. When you are going down, it's division by, okay, for each step it's division by 10. Just remember it's division only. And when you're going up, it's multiplication. All right, so you are here, this is you, and this is your destination. You want to be here, this is your destination. So this is you and you want to be here, you want to go here. You are going down, you are going down. So you are here, put your fingers here, okay, and go down. So how many steps you're taking? So don't count where you are, okay. So the first step you'll take is 1, 2, 3. 3 steps you're taking, isn't it? You're here, okay. Okay, you're here. So the first step you'll take will be centimeter. Second step will lead you to decimeter. Third step will lead you to meter. So how many steps you took? 3 steps you took. For each step 10, that means 10. So you took 3 steps, so it will be 3 zeros, which is 1000. You are going down, that means division. So division by 1000. So converting from millimeter to meter, it's division by 1000. Likewise, if you want to, suppose you are here, suppose you are in meters and you want to convert to millimeter. So you are here and you want to convert to this one, then it will be multiplication by 1000. Okay, all right. So so for example, 1 meter is equal to, so how many, if we have to convert to millimeter, then 1 meter will be how many millimeter? It will be 1000 millimeter, because you are here, okay, and you want to convert to this one. So this is your destination. So how many steps you take? 1, 2, 3. You are going up. From meter to millimeter, you are going up. That means multiplication. So while converting meter to millimeter, it will be multiplication by 1000. So it will be 1000 millimeter. I hope this is clear. If you don't know this thing, this is very important for you. A student of class 10 should know this. I was taught this by my tuition teacher in class 10, and I still remember this. This is very handy. Okay, so most of you may know it. Those of you who don't know it, this is important in science also. Okay, maths though, it's so important, especially in geometry part, surface areas and volumes. but in science also unit. So this is very important. So that's how we are converting, okay? Millimeter to meter, it's division by 1000. So you got this one. Then again, we'll do one more thing. Okay, well, let's remove this also, 0.5. Let's remove the decimal. So I'm going to write 5. And since the decimal is in the numerator, denominator will get one more extra 0, which is 10. Previously, it has got already 3. So the value becomes 5 into 10 to the power, how many zeros? 1, 2, 3, 4. Minus 4 meters, right? See, the zeros are at the denominator, 1, 2, 3, 4. So you will write 10 to the power minus 4. Alright, this minus indicates that the zeros are at the denominator. Next, so this part is done. Okay, this is the diameter. So this is the diameter. So this was the diameter. So diameter is this. So from the diameter we can get radius also. Remember, diameter ka half is radius. So your diameter is this one, 5 into 10 to the power minus 4 meter. So it's ka half, that means divide 5 by 2, which will give you, if you divide 5 by 2 by 5, you'll get 2.5 into 10 to the power minus 4 meter. This is the radius. Alright, so you'll get 2.5 into 10 to the power minus 4 meter. This is the radius. So now everything has been done. Now let's come back to our question. So we have to find length, okay? We have to find length, but before we find length, we have to find area. So let's find area. So to find length, we need to find length, we need to find area, because the formula, see, in order to find length, we need area first. Without area, we will not be getting this. We already have this, this is what we are supposed to find, but we also don't have this. So we need to find this first, and we are ready to find this because we have radius. Okay, to find area, the formula will be pi r square. So we are ready now. Okay, we are ready now. So to find length, we need to find area. So let's find area. So area, formula of area is pi r square. Okay, this is geometry only. So put the value of pi, which is 22 by 7 into radius, formula is 2.5 into 10 to the power minus 4 square. So 22 by 7 into, let's do like this, 2.5 ka square and then 10 to the power minus 4 ka square. Can we do like this? Yes, we can do like this. Okay, so 22 by 7 into 25 into 25 is 625, but this is 2.5. So the symbol will come after 2 places. And 10 to the power 4 to the 8 minus 8. Okay, so this is what we got. Next, we will multiply 6.25 with 22. So when we multiply 6.25 with 22, what we get? We get 13. Okay, we'll do one thing. We'll remove the decimal first from 6.25. So you write 625 and then 0.25 after the decimal. Okay, there are 2 zeros and this is in the numerator. So denominator will get 2 zeros because after the decimal there are 2 numbers, 1 and 2. 10 to the power minus 8. Then let's go up. Okay, let's go up. So what we have, this one can be written as 10 to the power minus 2 and 625 will multiply with 22. So when 625 multiplies with 22, what we'll get? We'll get 13750. 13750 and 7 is here into this 100. You write here 10 to the power minus 2 and you have got 10 to the power minus 8 also. Okay, then what you will do, you divide 13750 by 7. On division, you will get 1964.28. And then what answer will this be? Into 10 to the power minus 2 minus 8, it will be minus 10. So this is the value of area. So area value, we're getting us 1 196.4.28 into 10 to the power minus 10. Okay, let's bring the decimal from here to here. So I want to move the decimal from here to here. Okay, so for which, so if I want to move the decimal from here to here, what I have to do is I have to divide. So I have to divide. So how many places am I moving? 1, 2, 3 places. So I'll have to divide by 1000. So from where I'll bring that 1000? I'll take it from here. There are 10 zeros in the denominator. Okay, 10 to the power minus 10 means it's like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the power minus 10 means this only. Okay, so what I'll do, I'll take 3 zeros. So if I take 3 zeros, then 196.4.28, I'll take 3 zeros. So 1, 2, 3. Since I've only taken 3 zeros, no more 10, it will be just 7 because I've taken 3 zeros. So how many left? 1, 2, 3, 4, 5, 6, 7. So this becomes 10 to the power minus 7 because 3 zeros have been taken by me. Okay, so now what happened? This point will move here. So now 1.964 into 10 to the power minus 7. Okay, this is meter square. This kind of unit don't write in the process of calculation, but in the final answer you write it. Okay, or else you lose mark. But I don't encourage you to write everywhere because it makes the calculation very messy. So keep it clean, but do not forget to write it at the final answer. This is the final answer for area: 1.964 into 10 to the power minus 7 meter square. Okay, so now if we read the question, we have just found the area. So now we are ready to find L. Okay, so we will use this formula now. Okay, so let's erase this and then let us do in a new page. So remember, area has been found. It's 1.964 into 10 to the power minus 7 meter square. So let's erase all of this. Now we're ready to find L. Now we'll use the formula of resistivity, which is R is equal to rho L by A. Put 1 here, do cross multiplication and get the formula for L. So it is, okay, let's do here, rho L is here and then R into A. We need the formula for L. So R into A will remain there and rho goes below. Now let's substitute the values. So L is here, R value is 10, area value, what was the value of area? Area value is 1.964 into 10 to the power minus 7, and rho value is 1.68, but what, 1.6 into 10 to the power minus 8. Okay, not 1.68, it's 1.6 into 10 to the power minus 8. So what we will do is we will remove the decimals from the denominator and numerator one by one. So L is equal to 10 is here. Let's remove this decimal. So let's write without the decimal. So for removing the decimal, denominator gets 3 zeros because after the decimal there are 3 numbers, 1, 2, 3. Then 10 to the power minus 7, just keep it as it is, don't disturb him. Then we have 1.6, I'll write 16. So its decimal is gone. Since 1.6 is in the denominator, on removing its decimal will go to the denominator. So 110 will come here. And then 10 to the power minus 8. Now let's simplify this. So I see 3 zeros here. How many zeros do I see in the numerator? 2 zeros. 1, 2. So 1, 2 cancel. Alright, don't disturb these 2. So 4 fours are 16. 4 fours are 16, 17, 18, 19, so 3 in hand, 4 nines are 36, 4 ones are 4. So what you have is L is equal to 491 into 10 to the power minus 7, and you have got here 4 into 10 to the power minus 8. So L is equal to 491 divided by 4 tens are 40 into 10 to the power minus 7, 10 to the power minus 8. So let's divide 491 by 40. So on dividing, if you divide 491 by 40, what you'll get? You'll get 12.275, and then 10 to the power minus 8 and 10 to the power minus 7. So let's bring this up. So this will be 10 to the power minus 7 into 10 to the power 8. Okay, so in this case, what you're getting, 12.275 into 10 to the power 1. This is positive 8, this is negative 7. So 8 minus 7, 1. Okay, so 10 to the power 1 means 10 only. So you multiply this with, you multiply 12.275 with 10, and what you'll get? You get 122.275, 122.75. Okay, this was length, so it will be in meter. So this point has moved to these places. Okay, so this is the length. Okay, this is what the question wanted us to find. So we have actually found the answer. The question wanted us to find the length. What will be the length of this wire? So the length is 122.75. But we are not done. We have to find the second part. How much does the resistance change if the diameter is doubled? So if the diameter is doubled, how much does the resistance change? Well, the answer is the resistance will become less. The resistance will change by 1 by 4. Okay, 1 by 4. The resistance will become less by 1 by 4. But we have to calculate and show. So let's move to the second part. How much does the resistance change if the diameter is doubled? So the diameter is doubled. So let's say this is the previous diameter, and now the diameter is doubled. So the diameter is doubled. So let's say this is a new diameter. So previous diameter D. Okay. In the new one, this is the old one. Okay, and this is the new one. In the new one, the diameter is doubled, is it not? So double of the old one, so it will be 2D or not? Yes. Old one is single D, so in the new one it will be 2 times the old diameter, so it will be 2D. This D is the old diameter. In the new, okay, in the new diameter, how much does the resistance change if the diameter is doubled? We are doubling the diameter, so it will become 2D. Okay, then from here till here is radius, so this is the radius of the old wire. Now in the new wire, even the radius will be doubled. Remember this. Okay, remember this. So we are doing the second part now. How much does the resistance change if the diameter is doubled? So for the second part, now you write, when diameter is doubled. We are doing for this part now. So when diameter is doubled, the new diameter is equal to twice the old diameter, so it will be twice of the old diameter then also the new radius, it will also be twice the old radius, so it will be twice the old radius. Alright, now so let's calculate the new area, because every time we are given diameter we get to find the area. So new area, it will be pi r square. Remember, we are calculating the new area. We are calculating the new area. New area is sky area. So it is don't put the value. Okay, pi r square. It will be 2r square. It will be pi. This will become 4r square. So it is 4 pi r square. Pay attention to this one, pi r square. See, if you are to find the area of this one, it will be pi r square. Radius is r, okay. So you see, while calculating the area of the new wire, okay, while calculating the new area, what you're getting 4 pi r square. This pi r square is the old area. Okay, so this is the 4 times the old area. What you're getting is, okay, the new area is 4 times of the old area. So the new area which we have is 4 times of this area. Understood? So the new area that we have is the 4 times of this area. whatever it is. Suppose the area of this is 10. Suppose the area of this is 10. So the new area will be 10 times of 4, which is 40. It will be 40. That's what it is telling us. 4 times of the whole area. Understood? Now, but they want us to find the resistance, isn't it? So let us find the resistance. So now let's find the resistance and know how much resistance is affected, for which we'll use the same old formula of resistivity. So new resistance. So now we'll find the new resistance. So new resistance formula is R is equal to rho L by A. So R is equal to, don't put a value, rho will be rho only, okay. Then L also, let it be L. Area, it is what we just got, it is 4 of the whole area, na? 4A, okay. It will be 4 times of the whole area, 4A. So R is equal to, what you do is, you do like this, you remove 4 like this, okay, and put rho L by A. And then this rho L by A, this rho L by A, my dear students, is the all resistance. This is the all resistance. So 1 by 4, okay, this becomes the all resistance. This is the resistance of this wire. Okay, the resistance of this wire is rho L by A. And the new resistance is 1 by 4 of this one, rho L by A. So the new resistance is 1 by 4 of this value. So the new resistance which we got is 1 by 4 of the all resistance. So that's it. We just got the answer. So therefore, if diameter is doubled, comma, resistance becomes 1 by 4. This is the answer. Okay, if resistance become if diameter is doubled, resistance becomes 1 by 4 times. We can write like this. So this is question number 6. And then what is the next question? The next question is question number 7, about the Ohm's law, where we have to draw the graph also. So we will be doing question number 7. Okay, so let me erase this and let me write a question and get ready. So question number 7 has been written. Let's read the question together and solve the question together. Question number 7 reads, the values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistors are given below. So we have been given the values of current and potential difference. Now we are to plot a graph between V and I, between potential difference and current, which is called a VI graph, okay, and calculate the resistance of that resistor. So we will be drawing a VI graph. This question has got a graph. In exam you will be given a graph, so you will be drawing this graph in the graph paper. Here we will draw with our free hand, okay, we'll draw a freehand diagram, but in exam, remember, kindly ask for a graph paper and then draw it. That way your graph will be more accurate. If you draw freehand, I doubt, okay, that the graph may not be very straight, because we have to get a straight line. So let's draw a VI graph. Now for those students who are familiar with drawing graph, this is very easy for you, but there may be some students who struggle with graph. I know, okay, a student of class 10 still struggles with drawing graph. So remember, drawing graph is very easy. You just have to know the basics. So spend some time, okay, learning the basics of how to draw a graph, and I assure you the marks from statistics will be yours, okay. The statistics marks will be yours, because graph is very important and it's very easy to draw also. You just have to learn the basics, okay. So in every graph we have got two axes. We have got the y-axis, which is called the vertical axis, and we have got the x-axis, which runs horizontal, okay. The center is the origin. So here also we'll have, okay, we'll have both this, the y-axis which is vertical and the x-axis which runs horizontal. So let's draw the x-axis and the y-axis. Let's start with the y-axis first. So let this be the y-axis. Like I said, the line is not very straight. See, you do with scale and pencil. For me, let me just try with this free hand. My alarm clock is ringing again. So this is the y-axis, this is the x-axis, this here is the current. Okay, in a VI graph, the x-axis gets the current and the y-axis gets the potential difference. This is 0. This is also called the origin. Then now let's put the units, okay, like how much gap should I use on the x-axis and how much gap should I use on the y-axis. Let's start with the current. Looking at the values of current, 0.5, 1, 2, 3, 4, I can use 1, okay, 1 gap each. So let's use 1 gap each. So here the line is long enough, so I can use 1. So this is 1, keeping the same gap, okay, put 2, maintain the same gap, put 3, maintain the same gap, put 4, maintain the same gap, put 5. Now on the y-axis, let's look at the values. We have 1.6, 3.4, 6.7, 10.2, 13.2. So here, if I use 1, 1, 1, 1, okay, it will be very congested. So let me go for 2. So let me take 2. Even if I take 2, will it be alright? So 1, 2, 3. So 2, 4, 6, 8, 10, 12, 14. Possible, na? Let's take 2, 2. So 2, 4, 6, 8, 10, 12, 14. Now let's plot the values. So it's 0.5 and 1.6. So 0.5 for x for current. So it is here. Okay, this is 0, 1, so 0.5 is somewhere here. So it will be somewhere here. 0.5. And for voltage we have 1.6. So this is 0, this is 1. 1.6 means half of this one, so most likely it is here. So put a dot here. Okay. Next, current is 1. So current is 1 means we are using this line. We'll be using this line. And potential difference is 3.4. 3.4, this is 2, 3, 3.4 will be somewhere here, so it will be somewhere here. So let's put here. Next is current is 2. That means here we're going to use this one. And potential difference is 6.7. 6.7, so not even 7 but 6.7, so it will be somewhere here. So roughly somewhere here. Next, current is 3. For 3 it's 10.2. So current is 3. So current is 3. It's 10.2. This is 10, 10.2, almost 10 only. So somewhere here. And then next 4. For 4. And the value for potential difference is 13.2. So 12, 13, 13.2 will be somewhere here. So these are the values. These are the dots, sorry. And on joining this, we should be getting a straight line. Will we get a straight line? What do you say? Yes, we will be getting a straight line. Okay. A rough estimate, and we will be getting a straight line, see, like this now. So if you draw this in the actual graph paper, you will get a perfectly straight line. Okay. So this is a straight line. We are supposed to get a straight line. Now we are not done. We are just done with the first part, which is to draw a VI graph. Done. Now we have to calculate the resistance of the resistor. So for which we will be using Ohm's law, and we'll find the resistance of each of these, okay, values. So using Ohm's law, which is V is equal to IR. So let's put V is equal to IR. Let's find for this set first. Potential difference is 1.6. Current is 0.5. R we don't know. Keep R where it is. 1.6 is here. 0.5 comes below 0.6. Let's remove the decimal. So this becomes 16. This becomes 5. 0.5 decimal goes up. 1.6 decimal goes down. You're left with this. Cut this one. Cut this one. 5 will cut 16, or 5 will divide 16. If you divide 5 with 16, you get 3.2. So the answer is 3.2. So this is the value of R. So R value for this is 3.2. Okay, important. We'll be collecting these values. Next, let's go to this. Same formula, V is equal to IR. V value is 3.4. Current value is 1. 1.0 is 1, okay. R value is, we don't know. R we're supposed to find 3.4 divided by 1, which is 3.4. So R value here is 3.4. So R is equal to 3.4. We are done with two values. Let's continue. We have 3 more to find. Now these values. So V is equal to IR. V is 6.7. Current value is 2. 2.0 means 2. R. Keep R where he is. 6.7 divided by 2. Now we'll remove the decimal of 6.7, which will give me 67. So 67, and below you'll get 2 into 10, which is 20. So if, 67. So if we divide 67 by 20, what do we get? We get 3.35. 3.35 is the value of R. So R value here is 3.35. Next, we'll find for the fourth set, V is equal to IR, and then V value is 10.2, I value is 3, R is R, R is R, keep him there. 10.2 divided by 3, remove the decimal from 10.2, you write 102, and you'll get 30, and this. Now if we divide 102 by 30, what do we get? We get 3.4. So we get 3.4 is equal to R. So R value here is 3.4. Now we have one more to do. V is equal to IR. Then V value is 13.2. Current value is 4. And R is R. Keep R as it is. 13.2 down comes 4. Remove the decimal from 13.2, write 132, and down you write 40, and you get R. So when we divide when 132 gets divided by 40, what we get? We get 3.3. 3.3 is equal to R. So R value is 3.3. So these are the values of R, okay. Now we will erase this and calculate the answer. All we have to do is now take the average. So okay, we're writing this one. To find resistance, comma, we find mean resistance. So R is equal to, you add up all of this and then you divide by the number of resistances, because average formula is like this. Average formula equal to sum of all observation divided by number of observation. So we are going to find the average resistance. So we'll have to add all of this and divide by the number of observations. How many observations are there? 5. 1, 2, 3, 4, 5. So you add up all of this. 3.2 plus 3.4 plus 3.35 plus 3.4 plus 3.3, and how many are there? Number of observation 1, 2, 3, 4, 5. You divide by 5. Now if you add up 3.2 plus 3.3 2.4 plus 3.35 plus 3.4 plus 3.3. If you add up all of these, you will get 16.65. 16.65 divided by 5. And if you divide this, if you divide 16.65 by 5, what is the answer you get? You get 3.33. 3.33. So the answer is 3.33 ohm. So the final answer is 3.33 ohm. So this is the answer for question number 7. Okay, first the VI graph and then the resistance of the resistor, which is 3.3 ohm. All right, now I will erase this and write down the next question, and we'll solve the next question together. Question number 8 reads, when a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliamperes in the circuit. This is milliampere. Okay, next find the value of the resistance of the resistor. This is a very easy question. All we have to do is use Ohm's law and then get the answer. All we have to do is find the resistance only. All right, so let's first write down whatever values are given to us. So we write given. What is given to us? Potential difference is given to us. V is given to us 12 volt, and then current is given to us. I is given to us. It's 2.5 milliamperes. And then what we're supposed to find? We're supposed to find the value of R. See, this is direct Ohm's law. V is equal to IR, isn't it? So we'll be using Ohm's law here. Okay, so to solve this, we'll be using Ohm's law, using Ohm's OHMS. So using Ohm's law, which is V is equal to IR. But wait, first of all, we'll have to change this milliampere into ampere. So what we will do is, let's change this milliampere into ampere, for which I'll be removing this milli. So it will be 2.5 divided by 1000, and with that the milli goes away and you have your ampere. This, what you will do, you will write it like this: 2.5 into this 1000 will go up. Okay, you will write like this: 10 to the power minus 3 ampere. All right, so V is equal to IR. What is the value of V? V value you put, which is 12. I value is here 2.5 into 10 to the power minus 3, and R value is what we are supposed to find. So keeping R there, okay, keeping R where he is, 12 where he is, 2.5 into 10 to the power minus 3 goes below 12. All right, now what we will do is we'll remove the decimal value from 2.5. So 12 will be 12, this will be 25, and then 10 to the power minus 3 is here, and then here 10. This 10 is from the decimal at 2.5. all right, now what we will do, we'll cut. So 5 2s are 10, 5 5s are 25. So what you're getting 12 into 2. So we're getting 12 into 2. 12 into 2 is 24. So you'll get 24, and then you're getting 5 into 10 to the power minus 3 is equal to R. So what you do is we divide 25 by 4. So 25 will be divided by 4. So 5 4s are 20. 4 in hand, point. You get 0. 4 5 8s are 40. So what do you get? Let's write it here. So you're getting 4.8. You're getting 4.8. And then this 10 to the power minus 3, okay, will be brought up, which will give you into 10 to the power 3. All right, you're getting R. Now, this can be the answer, but then we want to remove this 10 to the power 3. So what we'll do is we'll convert it into kilo. Okay, we'll convert it into kilo ohm. Right now this is in ohm only. Okay, this answer is in ohm. We want to convert it into kilo ohm so that I can remove 10 to the power 3. So what I will do is, in order to bring kilo, I divide by 1000, and then this 10 to the power 3 is with me. Okay, or rather let me write here. Okay, it's same only. R you write like this, okay, 4.8 into 10 to the power 3. Okay, this and this are same only, so R is equal to 4.8. we are bringing kilo ohm, so we'll bring K. So for bringing K, I'm writing 1000. 10 to the power 3 means 1000 only. Okay, so this is now in kilo ohm. Okay, so this goes away, so R value is 4.8 kilo ohm. This is the answer. So till this much, this is in ohm only, but we want to remove this 10 to the power 3, so we are converting it to kilo ohm. So this is it. Okay, I'll end the video from here. So I have done 3 numericals again. In the next video, I'll do again further numericals. So make sure that you practice along, and then don't miss the next video also. So until then, okay, take good care and God bless you all.